Hey people! So today we're going to be talking about molarity. So that's, you can say the topic for today. Okay, molarity. This is a continuation from concentration that we looked at the other day. You know, percent VV, percent WV, ppm. I think we even looked at or mentioned about this thing called PBB. Now this one is called molarity. This is the one that you'll probably see very often in a chemistry laboratory. Oh yeah, if you see an acid solution somewhere or a base solution somewhere, they're most likely labeled in its molarity, which is concentration. Right? I mean, percent VV is great. I mean, when you look at a bottle of vinegar or a bottle of beer, that's what you'll see. And for some sort of saline solution, you may see percent WV. If you look at, water contamination, air contamination, stuff like that, they'll be using stuff like PPB. How much chlorine is in your local swimming pool, that could be ppm. I mean, those are great. But when it comes to in a chemical lab, you'll see molarity a whole lot. And what is this? What is molarity? What is this? The concentration unit. Well, here's the definition right here. That a molar concentration, which is molarity, is defined as the number of moles. Man, we're talking about moles again. Of solute per, I would say, a liter of solution. So the formula here, of course, is that concentration is equal to the number of mole of solutes over the volume in liters of solution. So you can abbreviate it as, C is equal to N divided by V, when N, of course, is the moles of solute, and V is the volume of solution in liters. Simple. A very simple thing to do, and let's do by checking out this question right here, example 1. What is the molarity of an NaCl solution if there are 3 moles of NaCl in 250 milliliters of solution? All right, okay, molar concentration is C, and you're looking at N divided by V, so it strictly right now tells you that you have 3 moles, and it tells you that there is 250 milliliter of solution. And you're not going to use 250, are you? Because volume is said to be at liters. So you're looking at 0.25 liters. So 3 divided by 0.25. Well, you can say, those of you who are mathematically savvy, is times 4. That's 12 m. So that's what we do. Of course, when we're indicating the molarity of a solution, we use M, which stands for molar concentration. Of course, you can say moles over liter. That's exactly what it is. And in some cases, you may even say 12 moles dot decimeter negative cube. Okay, that really means liters if you think about it. That really means per liter. Anyway, that's a very simple question. So let's take a look at another question that is not as simple. Question 2. Calculate the molarity if 450 milliliters of solution contains, let's check this out. 70 grams of KF. All right. Concentration is equal to moles over volume. I know volume is 0.45 liters. Yeah, can't trick me on that one. 70 grams? Wait a minute. This is moles. Which means I'm not going to put 70 here, am I? No, man, that will be ridiculous. I'm going to have to somehow change 70 to moles. How? I remember somebody told me something about molar mass. So 70 grams, I'm going to change that to moles. Okay? To do that, I need to divide that by the molar mass of KF. And the molar mass of KF is 58 grams per mole. All right. Grams cancel, of course. And then what we have here is just 70 divided by 58. That's 1.2 mole. Okay, so 70 grams of KF is really 1.2 mole. So let me plug this into my lovely molarity equation. So what I have here now is, of course, 1.2 divided by 0.45. The answer is 62.7 m. Okay. So I guess sometimes you're just going to have to be careful when you're reading these type of questions. Make sure what you are given is what you're going to put into your equation, or else you're going to be in a lot of trouble. All right, so let's do one more example, and I think you get the point. Here it is, question 3. Calculate the mass of NaOH required to make 500 milliliters of a 6 molar solution. All right, I mean, you're looking at mass. Obviously, the concentration equation doesn't have mass, but it has moles. And you can easily turn moles back into mass. I mean, that's not something you haven't done before. So let's do that. So the concentration here is 6m is equal to moles over volume. So in this case, you're looking at 0.5 liters. So moles right here, of course, is 3 moles. And it does say calculate the weight. It never says calculate the mole. So when usually, usually asks you, it's hardly ever calculate the mole of something. You should calculate the mass of something, because that's meaningful. How do you turn 3 moles of NaOH to mass of NaOH? Well, just like what we did before in the previous question, just going the other way. We're going to multiply by the molar mass of NaOH, which is 40. Okay, so your answer, of course, is 120 grams. Okay. But I don't like to do it like that. I usually like to do this using factor label method. I mean, you guys can always, or more likely, you should get used to doing this. 6 moles per liter times 0.5 liters. Liters cancel. And what you want mass, right? So 1 mole is 40 grams. So moles cancel. And of course, you will definitely get the same answer by, not looking into a formula. Right. Hey, that's molarity. So we've covered percent VV, percent WV, and ppm in the last video. I mean, now we covered molarity. That's pretty much it. That's really what you need to know. And the next time, okay, we're going to look at solutions preparation. Oh, man, that's important. That stuff is important. What happened when we add water to an already existing solution? Well, the answer, of course, is this is a dilution, isn't it? So in a dilution, concentration should decrease. I mean, how do we do that? How do we find out? On contrary, what happened if we decided to add solutes? I mean, you can pretty much bet the fact that the concentration is going to increase, but by how much? So the next video is going to be, whoa, important. Anyway, let's call it later.